controller, Singleton, and the observer pen. Yeah. So let's go to GTL and let's go to. Oh no, it's creator, isn't it? Yes. If you could just get us underway and start streaming there. ODS is up, but not streaming yet. Oh, OBS, right. Okay, so what I'm going to do is move up. Now, I started in the wiki, though, again, I haven't finished because I started the process, but then got a squeal from the master's students worried about their LaTeX thesis template. So I had to resolve that. But that's for professional programming. But if we go to so you've got access to this course. See, you've commented. Excellent. Under design patterns, I've started adding in the material from this lecture. I'll also put the lecture slides into the repository, but this gives a kind of written overview with the start of some of the stuff we're going to talk about today. Okay, so I'll be updating the wiki with some content as well. Okay, under design patterns. But if I go to slides, design patterns, go present. Okay, so what I thought I'd do is just go over a game loop, right? Because you've heard about a game loop, but that's a standard solution to doing gaming. Is a game loop, and also talk about. I'm going to try and get that to me. Yeah, that's fine. And talk about some of the design patterns, and there are a bunch of useful patterns at this place, gameprogrammingpatterns.com. I've grabbed some of the material from there. Also, these are from personal experience as a developer. So, the big one, the game architecture loop. So, really simply, there is kind of three stages. You grab your input, you update your world state, and then you display it. And then you grab input again, update your world state, and display it. Okay? Now, when you're doing this with a single core, and you've only got one process, therefore you have to wait for your input, then you do your update, then you do your display, and then you cycle. Right? Most modern computers actually have multiple CPUs, so they separate these off, right? And actually start doing some multi-threading. We're going to talk about these further. We're going to talk a wee bit about timing, and in C++, you can talk about things like a chrono standard library now. It used to be when we started, we had to do everything with like time.h, and that file was separate on Windows than it is on Linux, and so you had to have lots of conditional cases of where you were using things, and but now we can standardize that in C++, so accurate timing is embedded into the language itself. Multi-threading, we're going to talk a wee bit about frame rates and logic. So, standard logic. Inputs come from the player, AIs, or network. Right? So, the player gives you some sort of keyboard input. The AI can either be embedded in the world update, right? So you see, like, if you think of very physics-based AIs, right, which are just kind of gradient descent, they're a rock falling down a slope, right? You could call it AI because it's an animated object in the world, but it doesn't really give instructions as such. It's just, once it starts rolling down the hill, it's just the physics take over and it rolls down the hill, right? But some AIs you can think of as actually issuing instructions. Right? So if they issue instructions, then they produce some sort of input. How we map the input between what the player does and what the world wants. We did keyboard mapping in the graphics course, so you could change what the keys did. Right? So standard, an A key does what. And so you can sometimes have a separation between what the input the character is giving, the player is giving, and the input the game needs. And if you're wanting to use weird input devices, things like GlovePi are a program that maps any system input to any system output. So you can map the Wiimote shake to the A key, or you can make the balance board going heavy to the mouse click. Right? So you can map inputs. And we also look at what restrictions we have on inputs. Right? So sometimes you'll have like keyboard restrictions. So in the keyboard controller, you can actually implement some things around saying, okay, when you press a key, it issues 1, and then waits, and then does key repeat. So there's the keyboard driver can determine some of those limitations. So sometimes you will get instructions from your keyboard that aren't exactly what the keyboard is doing, because the keyboard driver changes the input to make it work more like with typing rather than a direct control. So sometimes there are restrictions. When we're moving and we're doing world updates, there are collision detections. So one of the challenges, when you first make a game, first sort of doing the very first attempt, you like press A and you move the character's X position. Yeah? So that is kind of how we started. Yeah. Press the key, something happens. Press the key, something happens. The challenge is, okay, when I get to the edge of the world, right, and I press the back key, I've got to hit the wall. And so I've got to have a check there that does that collision detection. Right? Now, moving objects versus static objects, not so bad, right? Because I just have to go through a list of all the static objects, check that I'm not going into them. Moving objects versus moving objects, right? Because if there's two of us and we both try and step into the same space, who gets to go there? Or do we neither of us get to go there? So do we collide before we get there? And like, how do you determine when we collide? Because here we weren't colliding. Here we are colliding. So do I do half a frame? Or a quarter of a frame? Or do I move a tenth of a frame and check and a tenth of a frame and check? How do I resolve when exactly we collided so I know when to stop us? Right? So that's part of the physics restrictions. And just pressing a key and having it do something directly is dangerous for world physics. Indirect update on actual world state. So one of the things you do once you've got a complex world that you're having to try and keep consistent, rather than having the A key directly change the world, the A key needs to kind of make a request of the physics and say, hey, I'd like to move my character there. And then the world gets to check its consistency. So yes, you can move there, or no, you can't. Right? So instead of direct manipulation of position, you kind of issue requests to the world, and the world updates you. We're going to talk a little. So that's kind of the input and update. We then have the rendering part. In the rendering aspect, if you're doing a model view controller pattern, right? You've got the model. You've got a view and a controller, right? So the model is the world state. The view is your graphics renderer, and the controller is the input, right? Slash the world update, right? So you put your physics engine as a controller, which is getting input from the player, and then the model is the current state of the world. So in games, we often do a very similar thing. We have a rendering decoupled, right, from the actual state, right? So you have the world state, and then you have a display of that world state. So often you'll have things like functions that map world XYZ position to screen XY position. Right? So you guys have done graphics, that's your camera position. Right? And so when you set up a camera on your world, when you want to move things, you move things in the world, and that affects where they appear on camera. Right? Unlike 2D games you might have done, where I directly change my XY on screen. Right? So as your games get more advanced, it actually makes a lot more sense to have the world representation independent of the screen representation. once you tie those very tightly together, it can get difficult to do multiplayer things, second string things, or more complex movements. Just the general issues get high. So if you think of the window, the screen as the window on the game, right? Only display the areas that can be seen, and we start doing things like the level of detail. Right? So in graphics, when things are very, very far away, you either have things like a far plane, you just cut them off and don't display them, or you have layered displays where items close, you render at full resolution. Items far away, you pick the smaller version. Right? So you're doing a kind of constant level of detail. Now, one of the interesting areas of level of detail that's coming up with the Vive and the Oculus Rift is foveated rendering, right? Where we know like they are adding eye tracking to the head-mounted display, so we know where your eyes are looking. So instead of rendering the whole world, what we do is we render at high resolution just the detail your eyes are currently looking at, and everything else we leave big and blurry. And so we don't have to do so much rendering. So it's kind of level of detail according to where your eyes are currently looking on the screen. Right? So that's already starting to come through, and they reckon that they'll be able to run the next generation 4K resolution of the screens using 1070s and 1080s by doing this with proper eye tracking.
If you're watching there,
yep. When you flick your eyes, yes, when you flick your eyes, it has to update that before your eyes get there, right? And so while your eyes are moving, the brain blurs out the image, right? While your eyes are in the middle of movement. When they get there, they then look at what's going on. One of the things that I've looked at and I've discussed, but I haven't seen doing this yet, which is the muscle tracking, because you can get a signal the eyes are about to move from the muscles as they tighten before the eyes actually start physically moving. You can detect the electrical signal that the brain sends to the eyes before you see the physical movement. There's a delay in the muscle as the muscles start to get tight. So there's a potential that instead of doing it sort of eye tracking, you do EMG around the eye. Then because you're wearing a headset, you can actually do that. You can put EMG around the eye and actually track muscle movement. The scary one, have any of you guys heard of Neurolace? Okay, so it's a slight Neurolace. So so this is now 2 years old. So amazing injectable neuromesh covers the brain and can control individual fascia, control it reads individual neurons. So what you do is you drill a wee hole in your head and you inject this fabric mesh that then unwraps over the surface of your brain and has the wireless connector so it can read your brain activity. Okay? Now, what's good about that is that it can then measure your motor cortex, and it can work out when you plan to make a movement, and so it can start responding before you know that you're making the movement. Right? Because the way consciousness works is that there's a kind of combination of bottom-up and top-down planning, so you can actually see an action plan occurring bottom-up before the person's aware that they're about to do the thing. Right? So there's a whole bunch of craziness going on in this brain. Yeah, apparently we're now bright and sunny. Do we need it for bright and sunny? No, you can probably... Okay. Yeah, that's okay. We can leave a little crack of light. So level of detail is going to be interesting in rendering. Right? So one is level of detail seen, but also now where we're looking. We also think about how we render for the other characters. Right? So when you have a game world, you could have NPCs having rendered output from the world. So one of the complaints that some players have is that the AI is cheating, because the AI gets direct access to the game state, right? And so the AI can just ask, where's player one? And you know, the computer, oh, this is their XYZ position. Okay, I'll aim there then, right? Rather than seeing that you're actually in cover and hidden behind something, right? Now, one way of getting around that is actually rendering an image for the AI to work with, and then do image processing on the rendered image to work out what the AI can actually see, and then have it respond to that. Right? So then your techniques on how do I get in cover and make sure the AI can't see me is kind of more embedded in the world, because the AI actually has to see you. Right? So if you make it hard for the AI to see you, then it is more difficult. Right? Whereas at the moment, if you're not in cover, right, by the definition of the game, then the AI can see you.
I've seen someone use like a cheating, where they ray trace from the player to the AI to check if the AI can see it.
Yeah.
And isn't that a little cheaper than processing the whole image?
Well, that depends on what's going on and how many AIs you have and what the point of rendering their images are and like what you're trying to simulate, right? So one of the things we're always doing in games is trying to save frame rate, right? With this, if your AIs are being simulated on the server, then they're not being simulated on your machine, right? So their behavior is done on a render farm somewhere. So you may really be rendering those. You may want to render it for replay value, right? So like the kill shots, where you want to see how something killed you, you're going to have to render those 5 seconds of what the AI could see just before it shot you. Anyway, then doing a scaled down version of that for the AI to do processing might be reasonable, right? So there are kind of a lot of questions around how you do animation, how you do the rendering, what you're doing rendering for, and also certainly when you've got networking environment, do I need to see exactly what you see, or is close enough good enough, right? So, for example, if my character is running, and I've got my foot down and my back foot up, and on your screen, I'm like that, but my torso position is the same, and I'm just cycling through my run animation. In your screen, you shoot my foot there. In my screen, that's not my foot. Does that matter? Or are you just hitting the volume that is me? And if you get near the volume that is me, that's all good. Right? So synchronizing animations between different rendering targets, is that required to be synchronized? Does the rendering require that you do pixel perfect or volume perfect collision? So that determines some of the things you can do with your gameplay, right? And some of the skills that are relevant in your game. Okay, we're also doing multi-processors. So unfortunately, because of workload issues and the kind of state of the courses, well, you guys don't have our GPU course, the multi-thread course or the GPU course. So we're going to have to do some GPU stuff and multi-threaded stuff here. We can do as much of that as you like. I have a whole course on multi-threading, so if you want me to compress it into an hour, I can try. What I could do is get Marius, me, and Christopher to all talk simultaneously about multi-threading. Just see if your brains can cope. You probably need to serialize that, right? But when you do a multi controller approach in multi-threading, one of the approaches is to say, let's make a physics update in one set of processes and the rendering on a different set of processes, right? So you might have noticed this, like with PhysX, you can run game physics on your old GPU card while you run rendering on your new GPU card, right? So when you buy a new GPU, you can put it in, leave the old GPU in, assign physics to the old GPU card, and then you get all of those cores running game physics while your graphics is being done on a separate GPU. Right? So there, you then have the loader which starts these two systems, and they communicate through world state. Right? But they initiated, and they've got a renderer and an updater, physics updater, and they're just running separately and communicating through this shared model of the world. Right? Where the physics updates the model, and the rendering displays the model. loading and saving is quite important. One of the things that a lot of people leave near the end is to load and save games, right? You think, oh, you know, we'll worry about loading and save games, we're just trying to get stuff on screen, right? So you kind of build the models and you start getting the world up and you start kind of getting shooting down and you leave saving and loading till later. I would advise actually to get game saving and loading done relatively early, because as soon as you want to start testing stuff, you want to be able to get to the point where you've got that stuff available. One of the easiest ways to do that is to load a state of the world where that stuff is currently active, rather than go through the start menu and go through all the getting to the game where it's doing things and then doing stuff. If you created a load, you can just load, right? And if you created a save key, you can just save the world state and then load it again, right? So it's really useful for debugging and testing. It's also very useful to start thinking about what you might want to do networking, right? How you might want to network with that. So I would think about loading and saving quite early. It makes you think about your world representation as well, which kind of helps you solidify what things are in the world. You can also start looking at how you would replay levels, because if you say that once you've got saving and loading, you can start looking at events and reloading events, and testing and debugging, right? So although it seems like you should do wait to loading and saving later, it's useful to put it in early. And if we have a look at a big game loop, you can do all of these things in a big game loop, right? So although I said, updates, like input, update, render, there could be player updates, set player input, compute restrictions, update the player state, update the world state, look at passive elements, pre-select the active zone for the render, for the game to render, look at the logic-based elements, sort according to their relevance, execute control mechanisms, update the state, AI-based. This is a list of what a game engine had for, and we've got presentation, all the things it needed to do. Right? But in essence, you can still strip these back to what's doing update, what's doing input, what's doing update, what's doing render. Okay, so game architecture, with those kinds of mistakes, we can have the renderer and the updater separate, getting input from the player, or input from the network, or input from the AI. And that's a standard solution. Within standard solution, within games, we have a lot of design patterns. So luckily, you guys aren't the first people to make games. Right? Now, there's some nice standard ways of doing games, and standard ways of dealing with particular issues. And as programmers, we start to share these standard solutions because they just make it easier to understand what's going on with each other's code. And also, you don't have to reinvent the wheel, right? Because we've got a good solution for this, and people have thought about it and worked on it. They are not necessarily just code templates, and I've in the past been very hesitant to show code because it's not use this template. It's a use this way of solving a problem in whatever language you're in whatever way makes sense. However, we will do some programming patterns today, and if you still want, we'll do some usability patterns next week. Except we decide that on Monday when we have a meeting, right? And you decide exactly what you want from the backlog. Okay. We're going to discuss this set of patterns quickly. So, command pattern, flyweight, singleton, strategy, factory, spatial index, and the composite pattern. You've got the observer pattern, which you've already heard of, which the listener pattern and the observer pattern are the same pattern, just with different names, I think. So I think the listener pattern is the other name for the observer pattern. And the so strategies and command patterns are kind of different ways of dealing with these. I also have added the event loop pattern on the website. I haven't added it here yet, but we can also talk about an event listener pattern as well. Right? So usually what we do in games is when you have inputs, particularly from the player, because you don't want to act on them immediately, because they need to be sort of wait until you've got time in the next frame to do the update. So we have this decoupling of time, which means we have one way of solving this is an event queue, where you push events to the queue and then you handle events out of the queue. Now you guys saw that in the graphics project. I created an event queue where you press a key and it adds the key event, and then the physics updater grabs the key event and processes it. Right? That allows you to have a bunch of events occur, and then in the next frame process all those events that occur. Right? So that's a relatively standard kind of event queue approach. In the multi-threaded course, we look at how you thread event queues so that you can have multiple threads all accessing the same standard queue without interrupting each other and breaking each other. Right? So there are ways of doing that. We can look at that. The command pattern. Okay, so you guys kind of always know. So how to remap a function from the input. Right? So the naive solution to this, right, the non-pattern version, is use a big switch statement. Right? And just put a switch statement with all the keys and just do everything, right? And you know, I get to have all the options and just check lots of switch statements and stuff, right? What the command pattern does is it would say, okay, no, let's turn these function calls into proper, full citizen actual objects, right? So the command pattern is function calls to do something are no longer just function calls, they're whole objects. They have an execute function within them, but then they're an object, so they have they're properties of the language. So instead of calling that function, we call execute on an object. Right? So in an OO language, it's a pattern where you can create sequences of objects, and it's easier to do undo calls on a stack of objects because your functions aren't just disconnected; they're actually instances of objects that you can store and then replay and use. Right? So you've kind of stepped away from just doing a straight function call, and that can be quite useful if you look at when you want to call unknown functions. Right? So you say, oh, maybe I'm in my idle, right? And my idle is to walk over there and walk back. But then I want to change that to be an idle where I walk over there and walk back. So instead of having to call a different function, I create an object, and I just swap the object that I'm pointing to as my command object. Right? And from the command point of view, I just call execute on whatever that object is. Right? That object does what it does. If I want to change what I do, I just swap out that object, bring in another object. Right? So you could think of it like the event object, right? So when you have an event object, you'd often have like the event object and the event data, right? And you just get events and you call get data on the event, right? You get the data. With this, you can call execute on the object, and whatever is inside that object's execute function is what gets run.
I was talking about, like, let's say you have the input is, let's say, one key, and that key will be, like you mentioned, an actual object moved from.
Yep.
So instead of calling input a switch a model move, you then have other objects for that.
Yeah. So
movement.
Yeah, and so.
I want to have a move object and it can do something execute.
Yeah.
And then you can call that with canceling that's in the model. Like, yeah, in the system it will see that okay, there's a move event active, you will move, and then when you call undo it, you'll see that oh there's an undo function.
Yeah, so because the undo can be attached directly to the object, right? Because this is now a function. Rather than just a function, it's a whole object. So you can have the function and its undo built into an execute and undo in that object. So you can tie two functions together and you can build a stack of objects that get executed, and you can swap in objects just by having a different object pointer, right? Because you look at the command object, you grab whatever command object fits the virtual function pattern, right? And if you look, and if we go to here, one of the patterns you can go and read further about is the command pattern. So the command pattern. So here it gives you the example of going, the standard if then else switch statement, where each key runs a different function. Right? So you do a key press into each function, and if I make that bigger, so you can see the code. Then with the command pattern, you run this virtual execute function. So you say a command has an execute, and then what I do is I create these instances of a class fire command, which has the execute function is the fire gun function. And so my input handler becomes simpler because I use these buttons all have pointers to commands. So when I want to change what a button does, I don't have to try and remap that. I just have a whatever object button X is pointing to, does it execute.
Yeah, I mean, extra layer.
So I add the extra layer of indirection, which means I can then swap out I can swap out these pointers, right, and just swap pointers around rather than having to do switcher statements and say, oh, go and look this up over here and find out what it is and come back.
Yeah, because like you could have moved one player and then moved another player, because player 1 moves and player 2 moves, and then you have a cancel and you will not know if it's player 1 or player 2.
Yeah.
If it goes through
but if it goes through this indirection layer,
yeah.
So you get these kind of, if you want to swap out the actor, you can change kind of actor.jump, and so now instead of the key will change to jump, and it will still kind of return what happens from the execute, right? So that's the command pattern, right? The flyweight pattern, because we basically use it when we did the event queue, and you guys had pointers to function. Did you guys cover function pointers in graphics? I think we did. Did we talk to you about function pointers? Do any of you know what a function pointer is? Aha, where did you cover function pointers?
We did it outside.
Aha, okay, some of you did. Have you guys done function pointers? To understand the command pattern, it's much easier if you understand function pointers. So, you guys know what a pointer is? Yeah, great. So, we have pointers. Pointers are used to point to memory, right? So you get, so we've basically got an indirection layer. You've got a piece of information here, which is a long integer, that has the memory address of a piece of data. Because these are von Neumann machines and they're Turing machines, code, data, and code are stored in memory. So functions are just data, which means they have a memory address where that function is. That is actually explicit memory address where the code for your function is stored in RAM that you're using operating. Now, instead of having a pointer to data, I can therefore just have a pointer which points to the start of a bunch of code instead of the start of a bunch of data. Which means I can then say, instead of executing whatever was going to come next in my list of code, I can point and say, well, actually, run over to there and run whatever code is over there. And that's just a pointer. It's pointed to a function that will execute. And so what I can do is I can update, I can have a list of functions, and I can take that pointer and say, well, at the moment it's pointing there, but, at runtime, you can say, well, actually, I want to run this code now, and just change where that pointer is pointing, and when it comes through its execution loop, it'll hit there, run that code down there, and then come back. All right? So instead of having the code all predefined, you now actually jump around within the code based on values you can set at runtime. It's like assembler, but done at C++. Yep, so with pointers and function pointers. The most obvious version of this is where you have objects, right, like the command pattern. And you can swap out a pointer to an object, right? Because an object has both code and data, right? Which means when you point to a different object, you point to a different block of code. Now, before they had those objects, they actually just had the straight function, and you could just go directly and change function. So yeah, so function pointers. We can play with function pointers. I've got some function pointer code actually in the 360 shared repo. If you've downloaded the Git repo, did any of you download the Git repo? No. If you download the 360 shared code Git repo, there is a function pointer block of code where I do stupid things with function pointers. So the flyweight pattern, we'll move through and try and get through. What's my time? So the flyweight pattern is something that we use in games quite a bit, because often in games you'll have many objects that are pretty much identical. Now you guys are all potentially unique enough that I might actually store you all as NPCs individually. Right? Because you've got quite a lot of features that are unique to you. However, the disk you're sitting at, I probably won't want to store each of those as its own object with its own, like all of the details about it, right? With its own texture and its own texture for its legs and its own model for its legs and everything being duplicated hundreds of times because all the disks are pretty much the same, right? So what would I need to know about the disk? If I just have a single model of disk, what would be different about each disk? Position. And in this room, you don't really even get orientation changes, right? There aren't any tables here that are on their side or tilted or upside down. Or you might want to allow, and then someone changes, no, the game broke. I can't represent that. But I could just use X, Y, and rotation, right? So their X, Y position in the room, because I don't even height because they're all the same. And their angular rotation. And so this is what we call a flyweight pattern, where I create one heavyweight disk, right, which has all the textures and has all the code associated with the disk, all the things you can do with the disk, all the disk object stuff. And then I create an array of X, Y angle, and those are flyweight objects. They're the objects with the minimum amount of data required to render each individual disk. So when I want to change a disk, I can change its flyweight, while the heavyweight object remains the same. So, so type A, code and static stuff. Type B, the variables that are unique for that instance, and unique for that disk. So you see this with swarm enemies. If you have trees, right? Instead of having each tree being a full object in your world, they're pretty much the same. Or we don't care. You create one object with all of the heavyweight details, and these just have the position parameter. Right, so that's a standard flyweight pattern for doing multiple objects that we kind of separate out the minimum required for the individuality of that object. Which means I could represent you all because I'm assuming things like your hearts are all probably pretty similar, your livers are pretty similar, your lungs are pretty similar. So I could create a whole bunch of humanoid objects and then just wrap you with your own texture mapping. Maybe a bit of scaling. But, you're probably individual enough that there's not much I can make the same. The singleton pattern. So you guys will use the singleton pattern. Are you comfortable with how the singleton pattern works, or do you think it's an anti-pattern? You don't like the singleton pattern? What don't you like about the singleton pattern?
Global.
You don't like the globalness of it. Right. Because you don't use global variables.
Not very much, no.
Because if you use global variables, then the singleton pattern pretty much is the same.
It's not really a problem now, though, since we know each other. But if you're on a team where you don't know who the other programmers, probably don't want them to sneak around in your code.
Right. So the challenge is when you make something in Singleton, they can instantiate your object and then start talking to it without your knowledge.
Yes.
Right. In theory, you should trust all of your co-developers, right? It's not supposed to be kind of a competitive coding environment where I try and write code that you can't use to try and keep you out. There are some environments like that. I will have to admit there are some teams that kind of try and firewall themselves from the rest of the team. They actually had this at FunCon. One of the guys was saying they had two different approaches to how they dealt with designers. So one group made a scripting tool. So the designers could script code, right? And like script things to happen. And they would just write the engine code and the designers would write the script. And they kept having problems because the designers would do stupid things with game logic that you just shouldn't do. And they'd abuse the script, right? So, for example, he was saying that the designer found a particular command that ran quite slowly, and so used that to slow the response of an AI down by getting it to check visibility. Because if it checked visibility, it would slow down, and so that would give the player the time to run past it. And then the engine people noticed that visibility was hitting their performance on the game quite badly, right? So they went to the critical path analysis. Oh look, we're spending all this time on visibility. Let's make that code run faster. Then the game will be better. And so they went in and changed the visibility calculation to cache it in case you were running it a second time, that it would just use the pre-calculation button. And then suddenly all the AI started killing the players because they weren't slowing them down because they'd made the check. Yeah. That's hard shit to find, right? Because why? What has happened? Why is this going on? Yeah, and the designers have forgotten that that's why they did it. So yeah, if you give other people in your team ability to access your code and they start doing stupid shit with it, then yes, I can see you get defensive. And so what he did is in their team, they didn't let the designers touch any code at all. No scripting, nothing like that. The designers had to come to a programmer and ask the programmer to do something for them. And they'd sit with the programmer while the programmer touched code, and the designers sort of described what they wanted. Because they felt that, it wasn't safe. So no, I understand the Singleton isn't safe. So some people don't like the Singleton pattern because you've got this kind of instantiate anytime, instantiate anywhere. If it exists, suddenly you're accessing it. If it doesn't exist, you get to create it for the first time, and then everyone has to access your one. There are some issues with the standard Singleton way of doing it. It does give you control over how people access the Singleton. Right? So one thing, because you can't get to the Singleton without going through its interface, you can log every time someone touches your code. Right? You can log, somebody's created, someone asked to instantiate it. So that piece of code is trying to use it. Oh look, they called a set, they called a get, they called a display on the Singleton. So you can log everything that comes into the Singleton, and therefore you know everybody who's trying to interact with you. Right? So you can be transparent. Whereas a global variable, you have no idea when someone starts using that shit. Right? Because they just start, they hammer it from anywhere. So it does add some to it. But yeah, so you can pass a global round to a parameter, so you know who gets the global. And you can define objects in a source file reference and using an extern mechanism. So there are a bunch of ways of externing things, and so you can say, well, this is externally defined, so don't worry about it until I compile the whole thing together. And so that can kind of act a bit like a Singleton, because everybody says, oh, that's external, except one person says, I will create that. So the extern feature can act that way. You will see Singletons used quite a lot in games because there is often one of something, right? It does create some challenges when you want there to be two of something. Right? So technically your mouse is not a Singleton, so most games treat mice as a single thing. So if you have two mice in, they control the same mouse pointer, but actually they get different events in Windows. So you do actually detect there are two mice, and so you can have two mice currently. Have you ever played games with two mice? Yeah, no, you have to get in, because you can't just use the mouse driver. You've got to get the Windows events, and the window event has a mouse ID buried in the event information. But most games don't pull out the event information. Yes, but you would have to render them both. Right? So in your game, you could render 2 mice pointers. No, Windows doesn't have a second mouse pointer, right? So it maps any mouse input to the same pointer. But you don't have to use the mouse pointer. You can go directly to the event queue, the system event queue, and work out what object generated the system event, work out which mouse it was, and then display in your game a 1 mouse here and 1 mouse here, and or have 2 mice games where like one controls movement and one controls aiming.
Do you have a game example?
I don't have a game example currently because it's been a long time since I've coded that stuff, but we can experiment with it if you want to try and play with 2 mice plugged into one machine and 2 mice games. It's quite possible to do. It's just, you know, not many people have a second mice that they can now so they can plug into their machine. Anyway, because that doesn't make much sense to most people. So singletons, we have old way of doing singletons. So have you guys seen singleton patterns? Okay. So very quickly, the trick of a singleton is that you're not allowed to, you have a private constructor, right? A private pointer and a private constructor for the object. And the reason you do the private constructor is that means you can't call new, you can't create a new version of the object. So it's private, so there's no way of creating it. But what you make public is a call to getting an instance. And you say, right, give me an instance. That's a public static public. And it does a check. If the instance is null, create a new instance. Otherwise, return the current instance. Right? So the programmer can never create a new version of it. They can only ask the instance, it checks to see if one exists anywhere in the program, generates that back. Right? Now you can also make this thread safe singleton. You've got to put in a bunch of blocks to say, hey, I'm the only one allowed to be doing this check at the moment because all the rest of you guys have to wait until I've finished. Once I've finished, you guys can check if it exists. Right? So there's a whole bunch of thread safety issues in here. But that technique is saying, if it exists, give me a pointer to it, otherwise create one. That allows kind of a lot of flexibility. You don't have to constantly check, has the object been created yet, before you start accessing it. Now, have any of you made web games? Games on the web? Because one of the challenges of doing JavaScript and games on the web is you don't know when the image, well, unless you explicitly put triggers in, you ask for entities and they're loading. And if you start using them before they've finished loading, you'll get errors. So you have to kind of do either wait until everything's finished and have a callback at the end of loading to say, you know, on load end, right? So once loading ended, then I can start playing stuff. Right? And that's why you have that bar, because the programmers have written in a thing saying, oh, I'm going to have to wait until everything's confirmed that it's loaded all the images before I can start using them. Right? And so that kind of, you get these kind of issues, you go wait for everyone else to be done before I can continue.
But the problem is,
Yeah.
But there are points.
Yeah.
And we check like it's not null, but it is not null because it has given an address, but it hasn't finished loading it, so then it starts using it.
And then you start using it, and it's broken, and and then it's just it's not nice. The modern C++ way, or a more modern C++ way, is creating like static standard shared pointers. You guys use shared pointers? Yeah. So shared pointers deal with your memory and say what kind of pointer it is. And so again, you have a private shared pointer, and you do this instance, if instance, then make shared thing, right? So that's when you create the pointer for it. Otherwise, you return the instance. Okay? So there are slightly different ways of writing this now in modern C++. And shared and unique pointers are different. have different features, so be careful of which one you use to make sure you get the right one. On the Singleton checklist, is it private? And so private static instance, define a public accessor. So this is a concept of lazy instantiation, right? So one of my colleagues, he didn't like singletons because he hated lazy instantiation. He hated this idea of, I don't know when this is going to be created. It'll just be created whenever it's needed. Right? No. I know what my game needs. So I will just create all of my singletons. When my game loads, I will just make all the singletons happen initially. So there was none of this lazy instantiation, just do it when you feel like. Because people are happier to wait on the loading screen while you allocate all your memory than they are to hit a button and suddenly you have to instantiate a singleton. Because it's the first time they happen to shoot an enemy and need an explosion. Okay? I don't want to sit there and create the explosion at the time you need it. I know you're going to blow stuff up. I'll make that on startup when you're not playing yet. Right? So laziness is not necessarily the best option in game.
And that's why I don't understand why people don't use static classes instead of singletons. Because it does the exact same thing. But the only reason I can see is that you don't want to allocate the memory until it happens.
Yeah.
Or two, you want to have restrict the number of instances. But then it's not named singleton anymore, but like you can have max 3 instances, for example. Then it would
Yes.
make sense. But like the static class does everything for you.
Yeah. So statics are the other way. It doesn't allow you to change the order in which things happen or when they happen. It doesn't do lazy instantiation. But
no, because it
it's easy.
And then have it.
Yeah. So a lot of games won't use the singleton pattern because of they know exactly what you're going to do in the game. So why don't I just start that up early? While you're sitting there waiting while I show you adverts on my game, right? Because this is one of the things we had in our company is we're doing flash games. And because we've done everything algorithmically, we didn't have massive images to load because we would just check graphics. Which means we could start we could hit play and we could start about half second. But strategically, we made you wait 3 seconds while we showed you our logo and showed you a loading bar because two things. One, so we could advertise at you, and two, you felt you were getting more if it took longer. Right? You feel the game's bigger because it took so long to load. So, yes, there's a bunch of playing with reality that games do.
I heard people react to, oh my god, this game is only 350 megabytes. What's wrong with it?
Yeah. So, and if you load too quickly, they think, oh, it must be a small game. Right? So sometimes you have to make people wait just so they feel like they're getting their money's worth.
I think the opposite. Something with several gigs, something about is really low.
Yeah.
A lot of unnecessary.
A lot of unnecessary shite they put in there for no reason. Yeah. So we've got the singleton pattern, which we can discuss. Right. Strategy patterns useful for creating objects whose behavior can change dynamically. Right. So this is a bit like the command, right? But here we have multiple strategies that an AI could take, for example, and then you swap out the strategy according to what you're trying to achieve. Right? So here we're not just mapping a single function, we're mapping a whole set of things. We're mapping that whole set. So it's a solution when you have once you start getting a really messy switch statement, where you have to kind of check, oh, what state am I in, and then go down and do a whole bunch of changes of things, you can actually swap that out with basically function pointers, object pointers, and get a similar effect. So class and finds are separate from memory functions. Memory algorithms can be changed at runtime. It's like function pointers with class, right? So we have some code with an example strategy pattern. Here, this is a flight strategy, a public strategy, and it has recalc strategy, point and float. So this is similar to the execute that you might have in a command pattern. And again, I have multiple versions of this, so 2 specific strategies that derive from the strategy class. So I can have an item strategy, fight strategy class, which I create, And then you have a client to the abstract strategy, and you have actually concrete individual strategies underneath it. Any one of those could be the one that I'm currently using. Right? So a class has a strategy. When it wants to change strategy, it just changes out what object it's got, so its current AI basically. Right? You swap out its brain.
I understand the thing that you calculate with the price from this document.
Yeah, so the client is just saying recalculate what I'm supposed to do. And if I want to change my strategy, I want to go from being idle to being attack, I just swap out the idle object with the attack object and tell it, do your thing, and it manages what my outputs as an AI will do. Yeah, just the point to do a strategy object is that you put whatever strategy you want to do, just put it there, and the client will sit here being the client. And, so it's a way of managing the change in behavior. Factory patterns? You've heard of factories? Yes. In terms of patterns and coding?
Yes.
Oh, good. Rather than, yes, there's a factory. It's down there. It makes stuff. It's a factory. It's a paper factory. We talk about concrete and abstract factories, but so part of the idea of strategy of a factory pattern is dealing with memory, because memory creation and deletion is a hassle. And so one thing you do is you put all of that in one place, and your factory will make stuff and will recycle things. Right? So if I have an enemy factory, I can ask the factory for an enemy, right? And generate an enemy form. And then I can release the enemy back to the factory. And then it can decide what to do with that. Either it deallocates the memory and frees it up, or it keeps it in a queue of, I've already got an memory allocated with its memory and its code. I'll just put it into like negative space so you can't see it and wait. The next time you ask for an enemy, I'll just give you one I prepared earlier and just change its positions to whatever you ask its positions to. Right? So it kind of puts it into an invisibility state, holds it, deals with the memory itself, and then hands it back. But for the rest of the program, I've said, hey, give me an enemy. Created an enemy for me. And I've released the enemy and freed the enemy. So the rest of the program looks like a normal new and release kind of mechanism. And the factory deals with making sure it produces what it needs, manages the memory, releases the memory, holds all of the objects that aren't being currently used. So, and you know, that allows interesting reuse. Sometimes you can do weird things like having unions. Did you guys do unions in coding? And Steve, did you use a union in memory? So you have two different types of things stored in the same piece of memory, depending on how you viewed it? Okay, so C has a neat function called union, where you can create two structs which share the same block of memory, and depending on which one, the way you look at it, depends on how that you interpret that memory.
So the memory block has to be like as large as the largest one?
Yes. So the memory block is as large as the largest one, and basically it's like doing a cast into a pointer. The memory, we cast it into zero, cast it to char, but it's a union of structs into that. And depending on however you look at it, depends on what it is. So it's a kind of wee memory trick. Factories can use those sort of memory tricks to avoid having to create new memory and manage the memory that you have in your code. So, an example of an abstract factory. So we have meshes, texts, and objects, and we have those are products, and we have an abstract factory which creates products. Okay. And so here we can have in the abstract factory create, and we give it a product ID. It does a switch on which of the products you pull to create, and it returns a product of that type. Right? So it manages the production and creation of a factory. Without the abstract class, you can just have create text, create mesh pointers to these classes, and within each class they have a create mesh, create object, and so you just call them according to what you need. The factory has all the creates and destroys steps stored in that. Okay, so I'll just push through and stop it. So, spatial index. You guys may have done this. Quad trees, off trees. Discuss those in graphics. Okay, so when I'm moving and I walk this way, who do I do collision detection with?
Right there.
Probably the people close would be the better idea, right? Because if I'm walking here, I probably need to do a collision detection with the static test, right? And if I'm over here, I'm going to do a static detection with your knee, right? So I'll do a collision. You might move your knee, so I need to check you've moved your knee other way, right? But I'm doing collision detection probably more sensibly with people close. Because I don't really need to collide with you guys over there, because it's really unlikely that I'm suddenly going to have to stop because you're in my way. Okay? So you need some way of indexing your world to say, well, how do I know who's close to me? Because I just ran through a list of the student names and their XY positions. I would start from A and start checking through my list of all students. But that's probably a stupid way of doing things. But if I just did like X, I could be checking all the way along all the row if I just did it by X. Or if I did it by Y, I'd just check all the way into that. So I have to kind of have some way of mapping who's close to people. And so a standard way of doing this is what's called a spatial index. And the idea is that I divide the world up and say, well, you guys are close to me. Okay? And instead of having a list of every agent, I just have a list of agents who are within certain cells. Right? So I have, like, I might create a pod here, and another one there, another one there, another one there. And as I walk through here, all the people in that square I'll check against as I walk through. And then, I no longer have to check them. I have to these guys, and then so I'm checking as I go through, right? So for a regular grid, you get this kind of, I make a grid of the world, and I have a pointer to all the items that are in that grid. And if one of you guys gets up and moves, I take your item and move it into the next grid position. And then as I move through, I just check with everyone who's in my spatial index. Now, that's faster than this because if I'm here, I don't need to collide with anyone. Nobody's anywhere near me. Once I move into this square, I've got one person to check. Here, I have two people to check. Another way of doing this is an adaptive quad tree, right, rather than regular grid, is where I say, okay, if you've got someone in an area, then you can represent one area, right? Because if there's too many people in an area, I break it up into smaller grid sizes, right? Try and break it up, say, well, where are the people in these areas? So where there are lots of you, I might have really fine detailed grid, and when there's nobody, I'll have a big open area, right? And that's when I just don't need to check against it. That's the idea of when the world gets busy, you create smaller spaces. You also have to look at the size of me with my regular grid. Right? Because in this regular grid, if I am a circle about that size, I'm going to have to check all four of those. And then as I move across, here I might just be able to check two of them, and here I'll be having to check all four. If I'm 2 hands big, I'm now having to check all 9 squares because I'm so enormous. So the number of squares you have to check depends on kind of the size of you and the size of the things you're trying to collide against. And so working out these grids does take some time. You have to know about the game. And I saw one of the students had a problem with Unreal because maximum speed in Unreal can't be changed at runtime. Right? So they set an object maximum speed, and then they want it to go faster, and it won't allow you to change maximum speed at runtime. And the reason why it won't allow you to change maximum speed at runtime is that relates to the physics engine and how far ahead it has to check to see whether you're in a collide. And so it works out the grid size according to how far you could have moved, the maximum speed frame, and that determines how big the grid needs to be. And it pre-calculates that when it compiles the game, and so at runtime you can't change that because it would have to rechange the entire grid.
Yeah. Because like for static objects, recreate the whole grid at compile time or at load time.
Yep.
But like the things that are moving, how often you have to...
Well, yeah, so with this one, you'd have to recalculate the quad tree all the time if you were doing it based entirely on the moving object. So usually you do this pre-calculation on your static objects and work out where the density of static objects are. And within there, you have people moving around. And sometimes what you say is, no, although this has nobody in it, I'll still break it up because I know a bunch of people might move through it. Right? So for dynamic objects, you might have a fine grid scale just so you can control the number of things you need to check against. But yeah, so in terms of updating this, it can be really slow. And so in Unreal, you have the speed value of an object. And that can vary from 0 to max speed. So if you want to change the speed of an object, you change its speed. You don't change its max speed. You set the max speed to the maximum speed that that object could ever travel in your game. And then the actual speed is the speed that moves up between 0 and max. Right? So, and again, that comes from understanding how it's having to do optimization on its maximum speed component. Of course, that was true 6 months ago. It might not be true of the current game engine. So they may have changed max speed because so many people were complaining about it being wrong. So they may have now like max limit speed or something that is actually the limit, and now you can change the max because they'll change the engine. Yep.
So this is why you can flip instructors and move too fast or something?
Some games, yeah. In some games, if the maximum if the way they've done collisions has treated the maximum speed as less than the maximum speed you're actually able to generate, then yes, you will be able to cut through. You'll also be able to teleport through something, because if you can get your whole body from one side of the barrier to the other side of the barrier within a frame, it never collided with the barrier. And so you can teleport through an object if you can go fast enough. Reality is not like that, guys. Quantum effects are neat and all, but they're not coordinated in the way that you'd like them to be. So yeah, you can do a bunch of collision tests. The last pattern I'll talk about is the composite pattern. This one we use quite a bit. The composite pattern is you guys have a bunch of objects. So with you guys, with images, for example, right? You might have a picture, and it might have some lines, and squares, and some objects in it. But one of the things in a picture could also be another little picture. So how we deal with that hierarchy of things is the composite pattern. And in the composite pattern, what you do is you have your graphics, which you can get children, you can move a child, you can add a child. And child can be linear lines, rectangles, textures, or another graphic, a picture, which is another one of these. So you can compose an object of things like itself in as many iterations as you are. Right? And so that idea of composing with an instance of yourself allows you to build up much, much larger and richer images without having to recreate the line every time. Right? So you use graphic programs where you can kind of do group objects. That's basically making a composite. So when you group a bunch of lines, you can copy them all, paste them all, and then now they're on the objects. So that idea you can have in your code as well with classes. Right? So that's a standard way of composing things together. And you can have recursors, so you can just keep composing a picture with another picture with another picture with another picture. And so the idea is you have a component, you have a leaf, and you have a composite. And there's one of ways to manipulate, right? So you guys can read this when you need to think, okay, I need to construct something with lots of iterations to itself. Now, that was the end of my talking at 10:30. So in the GPU here, I can now go work I can go to activity. No, where am I? More, log work, time spent, 2 hours, and adjust automatically, and third lecture, and log. Aha! I have now logged time to 3 hours, yay! See, so I've now logged time to that issue. I don't know if I can mark it as resolved yet, because I don't know, because what I haven't done is I haven't finished adding to the wiki pattern. I've added here, this is the event queue pattern, and here's the command pattern with a link. I was going to go through and put in this area, basically these, a short description and a link to where you could read more about it. Right? So you guys can come back to these. We've also got the video. I'll link the video that we're talking about them. And I'll update that. And so that's kind of the reference that you guys need. If you have questions, I mean, we give you access to edit this yourself as well, if you like. Because it's a wiki, right? So you guys can have access to read or write and edit and change as you should. So, fine, it's up to you guys how much you want to put into putting material you found interesting in here, or questions you have. But if you have questions or you have comments, you can put them in here. If you have a look at the Bitbucket code, and if I go, what's the fastest way up? Probably actually just go into Bitbucket. Logging in. Oh no, that's the wrong one. Yep. Should be that one. I had some issues because I was using my ntnu.edu email address. Because you know how American sites sometimes like you have an .edu. You can request your ntnu.edu email address so you look like you're from an American university. Because NTU has registered ntnu.edu as a domain. And so actually if you go to the English pages on NTNU, they're ntnu.edu, not .no. Did any of you notice that? Nope. So they put all their English pages on their edu site, which means they also have all of your email addresses are available at the edu site. So if you want an American university email address, you can request it. However, they're a bit arseholes that they remove your email address as soon as you're no longer employed, which is a bit rude, but which makes it very difficult. So, now I need to go. So if you have a look in shared code, you guys can download this. You should be able to download this. If you can't, well, try and see. There's some code playing. There's some design pattern stuff. I'm going to put lecture content and PDFs in there. There's pointer madness, which is, I think, both function pointers and walking around memory and playing with memory and doing crazy things to memory. So, you can have a look at the code. It's not beautiful code. Most of it's play code where I'm experimenting with stuff. So I'm not guaranteeing any of it's any good. But we can look at it and you can start playing with things. There is, I did a test of vectors versus lists and things. So there's kind of some playing code in here that you can have a look at. Most of it uses SPL. If you want to change it and use SPSS, FML, you can upload your own versions and we can do pull requests for that. We're also looking at sort of high score loggings and event queues and things. So, what we have is you guys have groups. You've started the design process in your groups. You guys haven't done game design before. So do we need to sit down with you with a game design document and start showing you what they look like? We'll give them some of that. You guys are comfortable that you've done some game designs before? And you've started designing your game? So what we do is next week I'd like to get you your ideas presented. If you want feedback, send us a copy or send us a link to your game design document. And then Mario and I can look over that and give you some feedback. Next week we'll look at on Monday, we'll look at the features that you've been editing and like you've been creating, and try and work out that we've covered all of the learning outcomes, like networking, AI, the things you need to do, and then update the game. I also need from you guys, I think, a class representative and a 3-person review committee for the course. So I need 3 of you to sit with me 3 times during the semester and tell me how I'm not responding to your needs. No, because that's apparently what we need to do. I also I need to ask some of you 3rd years if I can get your input from last semester on the courses, because they want reviews written up by the students, and yet they don't give you really resource to do it. Yeah. So we need to review the course and make sure that what we're doing is meeting your needs. And if you have concerns, you can go through both the class rep or through the review group. The review group is supposed to be trying to work out if we are providing you with what you need. Okay. We can do it 2 ways. We can either have a group of 3, or we can have the entire class being the reference group, and just have 3 meetings where we take notes about you giving me feedback about the course. So do you prefer to have a group of 3, or would you all just like to spend 10 minutes 3 times during the semester and give us feedback? The second one. So jointly responsible, just giving us feedback. Right. So
You can call it just the coming from the lecture.
that's what we'll do. We'll just give 10 minutes from the lecture and say, right, guys, you now need to give us feedback on the course, and somebody needs to write it down. No, not a Friday morning. No. So for next week, I was going to do some Shield usability patterns for the lecture, unless you tell me something different on Monday. Because Monday we have the review, Monday afternoon. I've put 2 hours in the schedule. The plan is to only use 1 hour with you guys reviewing where you're at and us giving you feedback. And then you telling me what I should put in the next sprint. I will, by the end of the sprint, have updated the wiki so that it's got the links to those patterns. Is there anything else you need me to do? Set up Jira projects. Okay. So what we can do now, and I think if I look at my schedule, is that kind of an individual thing. Oh, lots of emails. Right, at 11 I have my meeting with Miriam, who's my PhD student. I then have an hour between 12 and 1, and then I have another PhD student meeting, and then 2 to 4, and then we have the VR lab. I've mentioned this to you guys as well. The VR lab, we're trying to link with Trondheim, and so we're going to start trying on Wednesday evenings, having VR gaming evenings with the Trondheim guys, and try and create a sense of, shared, we're NTNU students, we're using HTC Vives, we should start gaming together and sharing experience of cool things we have in the Vive and stuff. Right? So we're going to start trying to do that on Wednesday evenings. So the students, the NTNU students are going to be there. I'm going to get our master students to check that they can be there, but you guys can probably join in on that if you're interested in checking out what the VR stuff. So Wednesday evenings we're thinking of having is the VR play evening. And we're going to set that up with Olson and try and make that work. Okay? But we're just starting out. We're going to try and run that over the semester, so it's not going to be a one-off. It's going to hopefully be a regular thing for people to play with VR. So if you guys want to do some setup, we can either start doing some setting up projects right now with you guys, and if we don't finish, you come back at 12, and I can continue doing setup. Okay. So I'll start with whoever wants to come up and see me now, and I'll start setting up projects. The other guys can either go away and come back at 12, or wait around until I leave at 11. Okay, so the Google Sheets, I do have a Google Sheets, and I was supposed to share it with you for groups. So, go to Sheets. So the 360 sheet has been set up. 2016 360 sheets, and so here, so I'll show you how this works quickly. So this is the shared sheet. It uses a lookup here to do an indirect concatenation of the name here with the lookup, so that if you change your name here, group 1, you fill in your student, your role, areas of responsibility, and if you want to, a description, features, and any tools, so you've got a wee description of the group, and then here is something, so if I change this to, so what one of you have a group name that you might like? Group 4. Okay, so group 4, if you go and you rename this, unfortunately this is how it has to work, so rename this to group 4, then under groups, you write in here group 4. This will look up and extract information from your individual sheet and put it into here, and it'll show the number of students, and we'll extract the title and type in. And what we have here is our ongoing update of like what stage are you at? Are you formed? You've got your design done. You've got your prototype working, and you've got something playable. So just keep like what state you're currently at, and we fill those up as we go. And then we generally put in comments, or you guys can put in comments each week that we meet up until the presentation. Okay, so that's our shared thing, and we make it shared so everyone can see it. We can, and I make it shared, and we can, anyone with link can edit, right? Which means if you share the link with other people, then they get to change everything, and I have to clean it up, and that's a really annoying thing. So I can either do that, or we can add each of your Gmails to here and just add you as editable. What's your preference? Link's fine? You're not going to abuse the link? Okay. Copy link. And shall I put that into the Confluence? And so if I go to the course, and I'll go down to edit, and go add your group details here. Save. You should now be able to see that link. Click on that link and go and edit this sheet. And that way you can put in, so we have got 1, 2, 3, 4, 5 groups. 6 groups. Oh, someone's in already. Oh, that's fast. You guys are hovering. Now, can you work out how to do this? And so all the students are listed here, just so we had them. But if you want to add a new group, you just go in there and then change its name and copy and paste stuff out of here. Right? So, oh, someone's adding sheet 10. So copy. Oh, they're moving around. Paste. Right, so, you know, use your Google Sheet thing. Team Bjorn, excellent. And one person's already in there. So, yeah, and I can also create links into the other areas and stuff. So I'll make that updated. But I use a bunch of Google, spreadsheet food and make things linked and try and get stats on stuff. Okay, so if you create groups there, once you create group names in here, I will then use those to make the projects. And if you list your usernames, because I think we added you as usernames, or did they add you as email addresses? I think we might have added you as email addresses. Yeah, so I've got usernames and I've got email addresses here. So what I can do is I can use those email addresses so long as you make sure that you name yourself correctly.
Do you want first name only? Or do you want full name?
First name should be fine. You don't have more than one person with the same first name at Peters? Martin. Yeah, Martin and Martin. Yeah, two Martins. Username's fine. Yeah. I did find an interesting side effect in Blackboard when you look at usernames, and you go participants, and you do a sort by username. In here, it's it looks like okay, it's sorted by username. That's fine, and you know how your username is generally generated from your first name and last name. There is an interesting side effect in the first year students, because that's not actually how Blackboard works. You might think it's how Blackboard works, but you'd be wrong. Because if I go and say user groups and go participants and go sort by first name, right, that's good. Abdi Rahman and Abu Bakaran, and you think, oh yeah, A-R-H, A-B, that's sorted by first name. Let's sort by username. Oh, this time it fixed it. So last time when I did, that's weird, because before I was getting the A-R-H as staying at the top, and now we moved. I'm not sure I trust Blackboard. But, so yeah, so we get this information about you guys. I don't know how we've got 103 people in first year. Yeah, we might have to add another tutor. Are any of you interested in being a tutor in first year?
Do I get paid?
Yes, you get paid. There's money and there's training. So if you're interested in helping us out, we might need a third person, because 102 seems a lot. Okay, so that's link is there. You guys can edit those groups. I can start making teams in Jira right now from groups that already exist. So we go to Jira and we go to now in Jira. We're going to set up projects. So I'm going to create projects. So which group already knows what they want to do? Who wants to come up here and start working with me? So we're about to create a group in Jira. Who wants to create their group in Jira right now? You're going to come up. Excellent. Okay, so do you know what kind of board you want? Do you want a Scrum board, a Kanban board, or a basic software development? You're going to go with Scrum? Okay. So with Scrum, you get sprints. Yep. You want sprints? So now we're going to select a software development workflow. This is the simplest workflow, but I want to go to select. Oh, actually, no. I'll change that when I get there, because it doesn't seem to be giving me options, but we can change that. Right, name. Go IMT. So, oh.
Keyboard is different than mine.
Yes. You just entered it.
Yeah.
So, right. Projects team. Team. I wonder if I can delete team. Delete projects. Now I need to be admin. Go on. Yeah. Okay, so projects. Create project. That's Scrum. It doesn't give me multiple life, so I'll select. And for team name, yeah, we should. Team Beyond. So, what do you want your your key to be. So when you do issue ITB minus number, and you commit to the project.